Good morning. My name is Rahul. I am working for the Salesforce as a lead engineer. Today, I want to talk about starting using the multiple zone to achieve the high availability. I have been working in software industry from past 13 years, and I have mostly been working as a backend engineer. Recently, I have been working on the infrastructure services, and that's where I got the opportunity to work on a problem where we wanted to make our infrastructure service very highly available, even though if there is a complete outage of one of the availability zone. So with that context, I will start with the slides. And the idea here is that in the modern application, we have to have a very high availability of the services, right? And then how can we achieve it, right? For the agenda, first I will be talking about the importance of the highly available fault tolerant system, and then the foundational principles, the different components in the architecture, and how we can use the Kubernetes to implement the same. And then I will also touch upon how we can have the consistent routing and at the end the opt. Before we actually talk about high available system, the first thing is that why do we need it, right? So in a modern day to day, their services, which if not up, they will be losing the money, and also if it's not up, then you are losing the customer trust. So in another way, again losing the money, right? So it is very important to make sure that your service is very highly available, and with the concept of the microservices, how we can achieve it. So the monolithic service is the problem with the monolithic service is that it's a single point of the failure, right? So that's where the microservices architecture comes into the picture. With the microservice architecture, we'll have the multiple. Well, we can start our services into the multiple zones. And let me explain about this. When I say multiple zones, the most of the cloud providers they have the multiple availability zone. And the availability zone, you can think it's a self-contained set of infrastructure. And when I say self-contained, it means that if something has to go wrong, it will not affect the other availability zone, right? So with that logic, if we have our service deployed in the multiple availability zone, what happens if one availability zone is down, your service is still functional, your service is still available, right? So the foundational principle, so as I explained, there are multiple availability zone. We can treat the each one separately. One going down should not affect the other one, right? The stateful services, we have to be very careful when we do the sharding between multiple availability zone for the stateful services, because the stateful services generally means that there is an state of the data with the part, right? So we have to think when the service upscale or downscale, how do we maintain the state of the data, right? The data locality, we should try to keep the data not flowing into the multiple zones, try to minimize the flow. Partial failure design, when there is issue with the one zone, the service should still be functional. And we need the operational transparency. We need to have the enough monitoring and the alerting to monitor the status of the services in the different availability zones. So architectural component, right? So now since we have multiple zones, our service is deployed in multiple zones, we need to know that which customer request will be served from the which zone, right? So that means that we need some kind of metadata service to provide that information. Think of this metadata service, which it's keep in track of the your customer versus which zone serves the customer, right? It's responsible mainly for the shard assignment. So whenever a new customer comes, it will be able to assign that particular customer to one or the existing shard. It will also be helpful monitoring the health of the services, and also routing policies, like whenever the request comes for the existing customer, which shard should serve the request. Sharding into the multiple zone also help reduce the blast radius. Okay. So service design for multi-zone resilience. So Enrich service registration that includes zone information, capacity indicators, and dependency relationships. enables intelligent client-side load balancing and scalability. A stateful component isolation, clear separation of stateful components from stateless processing logic. And hierarchical configuration will help us to maintain the global configuration, keeping the zone-specific configuration as an option to override. When we if you have microservices, you're implementing using the Kubernetes, these are the best practice to follow. You need to have the path distribution strategy. You also need to have the persistent volume management. The persistent volume management, whenever we create an stateful pod, we can actually have the pod affinity in the topology. The different pods should come up in a to fall into the different topology, right? The service consideration, and also we can have the zone aware scaling deployment, right? This will be helpful when you have the one zone down and then you want to redirect the traffic to the other zone. If you have the zone aware scaling, that time you don't have to worry about other zone able to handle all the traffic. Okay. I do want to talk a little bit more about the request routing and the load balancing. The metadata service which keeps the state of the which knows the state of all the zones. It also knows that which customer is being served from the which zone. So it will be able to act as an intelligent router and also as a load balancer. We also need to make sure that we are using the consistent hashing because the number of the zones is not fixed. It can we might have the requirement to add more zones or the requirement of removing a zone. In this case, we need to use the consistent hashing, which will, and we need to make sure that the data is being moved in the correct zone so that the customer can be served correctly. Okay. So for the consistency and state management, data consistency, if you have higher consistency requirement, then what you want to do before you replicate the data across the zone, you have to the request will only be successful if the data is replicated across all the zones, which is highly consistent. From the Kip theorem, you can know like consistency and availability goes hand to hand. So if you try to make the system high consistency, your availability will go for a toss. And the other way also, if you want to keep the system highly available, the consistency will go for a toss, right? So if you go for high consistency, you are saying that you want to write to all the zones before you confirm the completion of the request, which means that if any zone is not available, then you will not be able to write. So you are saying I'm going for the high consistency, but then you are reducing the availability. My suggestion is to go with the eventual consistency because our focus is the high availability. So it should be okay if the other zones eventually gets the data. And then zone aware database sharding. So we can like place complete the data partition within zone while maintaining the global consistency. For the conflict resolution, we can have the simple last right win, or maybe we can have the better sophisticated algorithm that depends on the requirement to requirement. It is also very important to have the monitoring and the observability. We need to make sure that the different zones, what are their capacity, and based on that, we have to pre-provision the another zone or increase the capacity of the zone. So it's very important to monitor the health of the services in the each zone. Since it's now multiple zone, debugging any issue is harder. That's why it is if you have a distributed testing, it will help you trace the issue and also having the logs will help find the issue better. This is also very important, the cost optimization. When we go for the high availability, what we are doing actually is duplicating everything, right? So we are duplicating infrastructure and then which means that the more cost. There are few things which we can do to make sure that we have a check on the cost. First thing is that we can, based on the perf test, we can right size the instance, right? So on the different zone. There is also a concept of the reverse reserved instance, which means that if we book the instance like in advance, which comes at the very discounted rate. So that can save us. We have to be careful, like how do we communicate between the zones. There are different options based on the cost. We can choose the one. The zone aware auto scaling policy. This will help us to not over provision the zone and only auto scale when it is needed. Yeah. Yeah. So operational best practice, we can actually have the CI/CD pipeline, which actually also have a canary. So before we deploy a zone, we can actually test our solution to reduce the blast radius. We also need to be make sure that the changes that we are doing is not zone dependent. So like your change work on the one zone and not onto the other. So your service need to be agnostic of it, and it should be able to work on the any zone. Okay, so in conclusion, your service across multiple zone will help you achieve the higher availability, but then there is additional complexity to maintain the metadata service which is required for the routing. There is additional cost and there is an additional complexity when you want to debug the issue. So depending on the application use, we need to see if charting across multiple zone is required. The one of the use case which I can think is like the database. When you have a database services where you actually store the data, if you shard your service on the multiple zone, then and then you replicate, right? So what happens in this case, even if one of the zone is down, you still will be able to serve the data from the other zone if it's serving a mission critical services, right? Or the tier 0 services. So if for those use cases, it makes sense. Yep. So I think I will stop here. Thank you very much.